Welcome to Lesson 3, everyone. In this session, we have 3 parts to complete. Please read carefully on Manage Back. So if you click Message, you will see Unit 6, Lesson 3, and you see the deadline here. Please read through it carefully as you progress through this video. Let's warm up with a Think, Pair, Share activity. Let's take a look at this image here. So here you see 4 different triangles. I want you to use Pythagorean theorem to think about, are these triangles right-angled or not? How can you tell? How can you prove that? You may measure the length of the sides of triangles if you want. They are actually drawn to scale. Okay, so in order to approach this question, or this set of questions, I would like to demonstrate your proof with proper visualization. Okay, welcome to use Jamboard, Google to share with everyone. Just in case if you don't know which one I am referring to, take a look at this one, Jamboard. You can actually log in with your Gmail and find it, okay? All right, so let's go back to the slide. So as you can read from the slide, I would challenge you with using a new tool to share your response. Try to find a way to record your rationale and upload to Manage Back. All right, so if you want to use QuickTime Player on Mac like me, you can click screen or audio recording to process. Okay, so it's up to you, but try to record this time. Now let's move on to apply Pythagorean theorem and some basic trigonometry. Let's look at the left one first. Okay, so let's review some basic relationships between Pythagorean theorem and triangles. As you can see from here, triangles, particularly right-angled triangles, are present all around us in the 3-dimensional space in our everyday lives. Many problems can be solved using Pythagorean theorem, although some problems may not be immediately obvious as triangular in nature. So for example, the length of the kite string and the horizontal distance from the holder. So we're looking at here the horizontal distance, and then we're looking at the height of the sky can be used to find the height at which the kite is flying. Okay, so as you can see from here, you might need to use trigonometry to find out the relationship of 3 sides. Okay, you also want to consider how tall the person is. So you have 1 meter here, you have 32 meters here, and then you have 39 degrees here. Okay, so think about that. You want to pause the video, look at the visual, and then try to calculate the answer. Don't forget about your decimals. Decimals will be your great friend, same as your scientific calculator. Okay, and then let's take a look at another one. Okay, so let's think about how you can use Pythagorean theorem to find the length of the side of the cone. So as you can see that I constantly highlight that in geometry, you need to cultivate the ability to translate words into images like this. Okay, so when you look at the words or the phrases, the length of the side of the cone, which one are we referring to? Are we talking about this? Are we talking about this? Or what are we talking about? We're actually talking about this side. Okay, so as you can see that the bottom of a cone would be a circle. So 4 here actually represent the radius. Okay, so can you try to find it? Okay, let's take a look at the bottom one. So you will see that we use Pythagorean theorem very often in our daily life as well. A staircase is a typical example. So right now you have the height here, you have the distance from the foot of the staircase to the wall here, can you find a right triangle here? And can you find the length of the staircase? Okay, so you guys are smart enough. You will see that that would be the hypotenuse and these two would be the legs. So you're welcome to use a squared plus b squared equals c squared to solve the problem. Okay, again, you might want to pause the video and try to calculate. Okay, so as you can see from this slide, number 3 is a similar question, but this time you don't really see the numbers on the image. Instead, you see the ramp is 12 meters and the base of the ramp is 9 meters. So what is the ramp? So ramp refers to here. So as you can see that this will be the base. Your goal is to find out the height of the ramp. So can you see the hidden right triangle here? Okay, so let's take a look at some variations through question number 4, 5, and 6. So take a look at this one. You're asked to find the length of the base of the triangle shown. So does this triangle look familiar to you? As you can see that it's very obvious, it's a isosceles triangle. So if this is 7 meters, then this side will be 7 meters as well. Okay, and then you can imagine this 2 meters long, it will be perpendicular to the base. So what can you think of right now? Have you thought of the bisector? Okay, so if you know this is bisector, then what is a feature? What are some features of bisector? Okay, as I mentioned that it will be perpendicular to the base and also the base will be equally divided into 2. Okay, so then you can see that you have a right triangle here to find out half of the base here. Okay, again, pause the video and then think for yourself. All right, so let's take a look at number 5. You want to find the length of the step side of the letter. Okay, so we're talking about the step side, this side. And again, you've got the height of the top of the letter. It's 2 meters. And you've got 1 meter here, which is the distance between the middle point, okay, and 1 foot of the letter. Can you find the length here, which is a hypotenuse of this right triangle? Number 6 is a little bit challenging. Okay, as you can see that you actually see multiple right triangles here. I'll leave it here for you to solve the problem, okay? And when you're solving the problems on these 2 slides, I also want you to think conceptually. Try to think about why is Pythagorean theorem useful in our daily lives. Try to be concrete in your reasoning. So for example, you can talk about why we see so many lines being perpendicular to one another in our daily lives, why hypotenuse seem to be obvious, seem to be visible every day. All right, so you will go back to manage back. As you can see that will cover part 1, the first 2 questions. Okay, let's go back to the slide. So the second part of this assignment, this lesson, you are invited, okay, let's take a look at part 2. You're invited to work on 4 worksheets. Okay, so if you go to tasking unit, you click what is proof, the final unit of the whole here. Okay, on your end, you should see the circles of worksheets directly. Okay, so you'll be asked to solve 2, 3, 4, and 5. Okay, so just a quick reminder, the first one is actually the handouts, the PDF version for the whole unit, and I actually use screenshot in the slide. So if you want to see the complete version, welcome to go to Manage Back and download this PDF here. Okay, But let's quickly take a look at what you're expected to do in these four worksheets. So the first one is solving proportions. As you click that, it directs you to this PDF. And as usual, you'll see the problems at the top and the answer at the bottom. Okay, so you learn about proportions when you're younger. I believe you learned about that in grade 6 or grade 7. Okay, can you find the missing value for each question? Okay, a quick reminder is that think about cross multiplication. So for the first one, as an example, you will multiply 6 and p, and it will be equal to 4 multiplied by 2. In other words, you're solving a one variable equation. 6p equals 2 equals 8. Can you find out p here? All right, so that's the first worksheet. The second worksheet, you're dealing with similar polygons. And similar polygons is actually an extension or application of proportions. The key is the idea of zooming in and zooming out. When one side is longer, the other sides need to be longer as well. So can you justify your statements here for these polygons? So as an example here, the first one, you can see that this is the length, this is the width of this rectangle, this is the length, this is the width as well. So think about when the length expand from 14 to 21. How about the proportion between 10 and 15? Is the proportion the same? Okay, so as you can see that polygons will be the extension of proportions. So you must work on solving proportions first, and then you work on similar polygons later. Okay, so that's the second worksheet. The third one, using similar polygons. So as you can see that this worksheet asks you to find out the missing values. And you want to find out the ratio or the proportions as well. Okay, so give it a try. Some questions might be difficult and you might want to use your calculator to calculate the proportions or ratios. Give it a try. Okay, the final worksheet for this lesson, you want to look at similar right triangles. Okay, this one can be a little bit challenging because as you can see that you might need to draw the overlapping triangles separately. Okay, so I will leave it as a challenge to you. Give it a try, okay? But if you find it too challenging and you are enough with the previous 3 worksheets, then you can leave it here for now, okay? I am sure at some point I will talk about how to solve the problems throughout the 4 worksheets. Okay, so that wraps up part 2 in the message. Okay, so my suggestion would be if you don't like to look at the screen all the time, print out the worksheets and work on papers and bring your answers and the solving process to our class meeting, either virtually or in person. Okay, so let's move on to part 3. So as you can see from here that on May 28th, that will be the first checking point for your geometric art group project. All right, so on this day or before this day, you want to decide your group members and share the draft proposal on Google Doc with Ms. Lai. So I would suggest that you open the Google Doc with your group partners and you just email me. I'll take a look and I'll use the comment mode to give you some feedback as the time progresses. You want to email me your Google Doc before 5 a.m. on May 28th. So I have some time to take a look and then give you some feedback in our class meeting. I will schedule some time with you to meet individually or as a group. Okay, and I'm not sure if at the time Zoom will be stable, but just keep in mind that I will let you know if we're going to use Google Meet or Zoom for the meeting. Okay, so just in case that you don't remember what I talked about in the first video, just a quick cap. You go to calendar. You should be able to see all the check-in points, May 28th, May 4th. Okay, sorry, not May 4th, June 4th, and June 11th and June 18th. And then the final deadline is the 21st of June. And then you will see all the details for this project here on June 21st, the second green box. All right, so this wraps up this video. So keep in mind that it might take you some time to finish the 4 worksheets here. Give yourself some time and don't hesitate to ask for help either from me or from your classmate. But the key is to find answers first on your own. Thank you for watching, and I hope that I can see you soon in the Zoom classroom or in the real classroom.